Hello everyone. So today in this runtime generated terrain system, we are going to address removing the tree instances in the distance when we remove tiles from the landscape. So at the moment, let's say let me move the character back so that we can see some tiles in the distance disappear. See, that tile got disappeared here, but the trees are still there here also. So what we want to do is removing these foliage instances as well. So that's the issue we are going to address today. And before we get started, as always, I'd like to remind you, you can download the project files of this project and all other projects that I have done in my channel. So to the date, there are over 1700 videos, and for each video you can download the project file once you become a member without a limit in Patreon page. Link would be in the description below. Alright, so let's get started. So let me open the BP world. So in this video, runtime foliage generation video, we worked on how do we spawn foliage. So if you haven't watched that, I recommend you to watch it. This is freely available in YouTube. So there is a function here, generate foliage tile. This is the function where we add foliage instances. So the first thing is we need a way to know what foliage instances belongs to what tile. So foliage generation part happens exclusively in blueprint side, which is this function. So what we can do is here, when we so for foliage, here we have foliage instances. Here, this get instances overlapping box. So we can use this to find out what foliage instances relevant to a certain tile. So then we can remove these instances by remove instances and plug these instances that is within a certain box. So what we have to do is now is when we remove a tile, we need to find out the lowest min point. So that means if the tile is, consider this a square, this point in one end and the other point in the one end, one should have the minimum height and the other point should have the maximum height possible. Okay, so draw tile. This is where we draw the tile, and here we only returns the tile that the section index of the tile that we either replaced or created. But after doing that, we can't access the vertex information because that tile is already updated. So before we doing the update, we should calculate the things required to create this box. So I think if we have a function that we can call here just to remove the foliage instances, that would be easier. But everything related to foliage is inside blueprints. So here I'll add a new view function. Using the type blueprint implementable. Blueprint implementable event, and it should be void remove foliage tile. We need to give an index, const int tile index, right? Then so this is a blueprint implementable event with the input. So the way we call this is, we can just call it like this, and then compile. Now here we can implement that event, remove the foliage tile. So here we get the tile index. Okay, wait, hold on, let's convert this to a function. That would be easier rather than event, so we can have local variables also. So now here I deleted that event I created and compile. Okay, now override remove foliage tile. Okay, cool. Now let me just cut this part, paste it here. Now let's calculate using the terrain mesh. We can get mesh get section using this tile and now we can get the first element. That should be the one of the ends. I'll promote this to a local variable. I'll call it first, and then the last one. So to get the last one, we can get last index of this array and get that element. I'll promote this to another local variable. I'll call it last. Okay, right, and after that, so from the first one, let's here to make this box min, we can, how can we do it? We make vector here, and from the first we can split. So xy coordinates are fine. I'll get those two and z. So what could be the minimum value for our world? So here I have this 20,000 as the mountain height and 2,000 as boulder height. So maybe let's get those two. Mount get mountain height, get boulder height, add these two together. I'm not 100% sure about this number, but this should work. And if I multiply this minus with -1, that should be the lowest point we can get. So first is like this, and max, so max make vector, we can get the last just like before and get x and y. One more thing, I think we need to get that the location and add to these both variables to get world space. Okay, here without the minus part. Right, I think that's all we have to do. Oh, finally return. We don't really need a return, but yeah, let's return this. Okay, save. Right, time to test. Sorry, let me go to the top view so we can easily see that and simulate. Oh, when we simulate we can't move the player. So, right. To make it easier for testing, I'll manually move the player. So you, from these red patches, that's foliages. If I move it here, yeah, I think it's working. See, no more red patches. If I process, what's causing the performance hit? The foliage instance removal takes too much performance. Well, see, so like even if I leave foliage there, it doesn't make such a performance cost. So I'm not really happy with this. So what can we do about this? So to test what is actually causing the function, causing the most performance, I wanted to know if it is removing instances or this calculation. So I just set it to a new variable so that this function calculation will still happen, and here this is the result. If I go up and reject and move the character, let's wait until the calculations are over. Tile generation, if I move, see, we don't get much of a performance hit when we don't delete the instances. So the conclusion is removing the instances is costly. So perhaps instead of removing, what if we just relocate them? Okay, let's try something else instead of removing them. So I'll promote this to a variable. I'll call it replaceable foliage instances. Okay, and I'll put this under foliage section, and instead of directly setting this, I'll get this and append this new found array and return. So these foliages will not be removed right away, rather they will be replaced. Okay, and then here when we add foliage instances, what we do is add instance. So instead of adding, what if we get an instance from here and update the location? How do we do that? Okay, here let me get the replaceable foliage instances and has Now, let's check the length to see if we have elements here, and if the length is larger than 0, that means we have elements. So that means instead of adding, we can update. So we should only add new instances if we don't have any replaceable instances. So here, if we have, we can get again foliage update instance transform, and instance index would be from the replaceable instances we can get a reference to the first one, and after that we should remove it. Remove index 0, and the values location like this, rotation same as here, scale here, and world space. I'm not sure if I should make this render state dirty yet. Alright, let's see if this method works. Let's wait till the tiles are all generated. Well, by accident I had disconnected this, so that's why it was not working. So yeah, it seems working. Let me test. Go here. Now move the character. Let me move it. See? Now the instances are moved, and it doesn't seem like we have much of a performance hit as well. See? Oh wait, why tiles are not added here? Did it break? Oh, here we got an error. Okay, I guess we should have added some. Check if the last index is greater than 0. I'm not sure if that is the exact reason that broke the algorithm. Let's see. Okay, reject. Let's move the character. Yeah, seems working, but here we didn't get any foliage. Why? So it's not perfect, it breaks randomly, and after this point it's broken. Oh wait, the reason could be this marker end state. So it should work if okay, I'm pretty sure this is the reason. Right, let's see. Okay, object, move the character. Yeah, it works perfectly. Yes, nice. But does it cost more performance now? Well, certainly it's not bad as before. It's better than before. Earlier it was going, we were having spikes that goes like this. So this is definitely better. But does this... you should only set this to true for the last instance. Okay. So this is where we add foliage instances. So maybe this is executed when foliage add-in is complete. So we don't have a way to custom mark dirty. This is networking, right? So we can, what if we just call update instance transform for 0, get instance transform. This is just to mark this as dirty, no real reason. Let's just do this and see. Did I remove the dirty flag from here? Yeah. Just to see if we can save some performance. Okay. Let's wait till the generation complete, right? Okay. Now I don't really see a visible improvement of performance, but I guess that's working, because here you see the foliage is updated quickly, instantly. So yeah, I think we can now stop this episode right here. So we have a better way of updating using existing instances of the foliages and updating them rather than creating new ones, so that we can get rid of the foliage instances in the distance while adding new foliages up front. So yeah, you can see some foliages are there, but they will be eventually get replaced when we add new tiles. Yeah, that's gone now. Alright, so finally we can stop this episode right here. So thanks again for watching. As always, updated project files will be available for download in the Patreon page. Link would be in the description below, and see you in another episode. Goodbye.